What is up, everybody? Hopefully that wasn't too loud and you're now like, oh, my ear. All right, so in class we kind of reviewed really quickly standard deviation, okay? That's saying like, all right, everyone's this tall. Let's say the average male height in America is 5'10". Well, that doesn't mean the majority of people are 5'10". That means the majority of them are really close to 5'10". So what they do is they find the average. Boom, it's right in the middle. The average is 5'10", but we need some wiggle room to kind of share where they're at. That wiggle room is called standard deviation. How far off from 5'10" is the majority of people? So I want to show you guys how to find standard deviation, give you guys a chance to practice it, and go from there. You will need your textbook. So the textbook on page 334 shows how to do it as well, and that's what I'm going to be doing. All right, guys, so here on page 334, in example 4, it's finding a standard deviation, okay? This is something I wanted to show you guys. It's a very complicated procedure. I shouldn't say that. It's actually not too complicated. It looks complicated, but it's so useful in data and statistics to understand how far off an average can be. So I wanted to show you where it's at in your textbook, and now I'm going to show you how to do it. All right, so standard deviation. Right here we have the standard deviation formula. The square root of the sum of the data point minus the average squared, and then divided by how many there are. Basically, we're finding the average of how far away from the average the data points are. Let me give you kind of a little vocabulary. X bar, so this one right here, that stands for the average of the data set, what the average is. And we'll find that here in a second. X sub n represents the individual data points. And n is how many data points there are. So for example, let's say we have a length of cat's tails. Kind of a random little thing there, but length of cat's tails, right? And let's say we have 5 cats. And one cat's tail is 9 inches long. Another one is 6 inches. One of them has 12 inches. The other has 7 inches. And the last has 8 inches. Okay? So those are the cat's tails. We went out and captured cats and randomly measured the length of their tails. Out of it. Now, in order to find the standard deviation, we need to know the average. That means we need to take all of these, add them up, and divide by 5. Okay? So, hand out the calculator. I could probably do this in my head if I need to, but 9 plus 6 plus 12 plus 7 plus 8 equals 42. Divide that by 5, and the answer is 8.4. All right, 8.4 is my okay, so with that being said, that's my x bar. Now, I need to take each point, subtract it from the average, and square them and add them all up. So that means I need to take 9, subtract it from the x bar, which is 8.4. So take 9 and subtract 8.4. I need to take 6 and subtract 8.4. I need to take 12 and subtract 8.4, 7 minus 8.4, and 8 minus 8.4. Okay? That will tell me the distance from each data point to the average. Pause it and do it real quick. Okay, so I just paused it, did the math, and here's what I got. I subtracted each data point from the average and found this. Okay, that was that x sub n minus x bar. Now it says I need to square them. So I need to take each one of these and square them. The reason we're doing that is these negative numbers. We cannot take the square root of negative numbers. It's impossible to do. So therefore we have to make them positive. And by doing that, we are going to square them. We're going to square them to make them positive. And then we do the square root at the end to undo the squaring. Remember, square roots and exponents are opposites of one another. So I'm now going to take each one of these points and I'm going to square them, just like this, okay? Take this, square it, take that, square it. I'll pause it, do it, and be right back. All right, I'm back. I subtracted them, I squared them, and here's what I meant. So I've done this. I've taken it, subtracted x bar, squared it. Now I need to find the sum of them. I need to add them all up and divide it by how many there are. I need to find the average of these new numbers and then ultimately take the square root. So I need to take this and add them all up. So I get 3.36 plus 5.76 plus 12.96 and so on and so forth. Add them all up and find their average. All right, so I added them all up. I got 21.2, but I need to find the average. So I need to take 21.2, I need to divide it by 5, and I get roughly 4.24. Okay, here's one last step. So I subtracted, I squared, I added them up, and I found the average, and last is to take the square root. So I have to take 4.24 and take the square root. So the second x squared on the calculator. I go 4.24, I hit enter, and I get 2.06. So roughly 2.06 is my standard deviation. That means a cat's length, or average tail length of our cats, is 8.4. 8.4 plus or minus 8.4 plus or minus 2.06 inches. So in order for that cat to be average, it has to have a tail length of roughly 8.4 inches plus or minus 2.06. All right, so let me just kind of sum it all up, what I just did, okay? So here's the formula, square root of the sum of x sub n minus x bar squared divided by n. What I did is I took each data point. I took each data point, whatever they were. I think I had 5 of them, okay? That's sub n. I took each data point, and then I took the average. So here's x sub n. I took the average, and I subtracted it. Okay, when I was done with that, I then took the subtraction and I squared each one of those. So I subtracted them and then I squared them. So on and so forth. Once I was done with that, I found the average. I added them all up and then I found the average of them. Found the average, so it's x sub n minus x squared. I added them all up and found the average, and the last step was I took the square root. I know it looks a little complicated, but try it out. Give it a shot. Follow along with it. Use YouTube. Give it a shot. No worries. I'm not grading you on this. I'm just wanting to show you kind of some interesting things. Thanks, guys.